Hello everyone, I am Aparna here going to present on the topic of explainable AI in drought forecasting. This was a paper which is being published in the Journal of Machine Learning with Applications in the year 2021. These are the contents I am going to present on my following slides. What are the motivations behind this study? Why this study have been conducted? So understanding the influence of climate drivers towards the drought occurrence is important. In the changing climate scenario, every extreme is increasing very severely. So in this scenario, we need to understand what are the climatic variables which influences the occurrence of these extremes. So in this study, we are focusing on how the drought occurrence is being driven by different climatic variables. The climatic variables may be like rainfall or La Nina or El Nino or maybe anything else other than those things. And now we'll consider in what context, means how the machine learning can help us in drought forecasting. So in this case, forecasting of the SPI, drought index, using the LSTM for New South Wales, which is situated in Australia. This have been studied in this paper. So next we'll discuss how it affects drought forecasting, how the safely additive explanation can be used to interpret the drought forecasting. Review of literature. In the year 2015, Dio and Sahin found that data-driven tools are found to be an expeditious tool for drought forecasting. Dixit and others in the year of 2021, they described that the findings from a study shows an improvement relative to machine learning models for a lead time of 1 month in terms of different drought characteristics. This show the abstract of the paper in a pictorial view. So here what happens, the drought forecasting an explainable model, how this model works. First there is the data collection. The data collection will be there, then explanation using safely, and then also applying the LSTM architecture. And for this all we use the SPI 12 calculation for data pre-processing. Here I describe the brief objectives of this study. So the first objective was forecast of SPI 12 at a lead time of 3 months using the LSTM. Second one is interpret the forecasted model using SHAP. And the third one is examine the interpretation result from different reasons. So these things we'll detailedly discuss in the next slides. Introduction. Droughts are one of the disastrous natural hazards which has severe impacts on agricultural production, economy and society. Droughts are crippling phenomena. We never know when it starts and when it ends. It is difficult to predict when it started and when it's going to end. So one of the critical steps for effective drought management is developing a robust forecasting model and understanding how the variables affect the model outcomes. The number of studies on natural hazard also have been increased in the 21st century. This increase in the natural hazard study is due to the changing climate, and this leads to more number of extremes whole over the world. So in this case, the precipitations plays an important role in the beginning of the drought. So deficiency of precipitations leads to the meteorological drought, which further lead to the hydrological drought because of reduction in water availability in the water resources like the ponds, rivers and reservoirs. And then it tends to further lead to agricultural drought, and becoming all these things sometimes leads to the socio-economic impact, and which is very severe drought conditions and which is very dangerous condition for the human society. So in this case also, this is not mean that hydrological and agricultural drought will only occur after chronologically after the meteorological drought. It could be possible either way. Any drought can occur at any time, but here we'll consider the meteorological drought which is which occurs due to the lack of precipitations or the deficiency of the precipitation. There are many types of indexes to define a drought, but here we are considering the standard precipitation index, which is mostly used by meteorological several researchers to define meteorological drought. Standard Precipitation Index or SPI was conceptualized in the year of 1993. It involves the fitting of a gamma probability density function for the distribution of monthly precipitation data at different time scales. So what in this case there are several values of SPI is there. You can go for SPI 1, SPI 2, SPI 3 or likewise SPI 12 also. In this study they have considered SPI 12. So what does that sense? In case of SPI 1, they just consider the 1 month data for prediction for analyzing the drought. If the drought has been occurred in this single one period of month, they consider that. But in SPI 12, they consider all the previous 12 months data sets. In this case, the SPI values indicate what drought categories are mentioned. So in this case, we can see that drought are generalized when the value is less than minus 1.5. So that will be severely dry conditions and also leads to drought. Here we can see how the SPI values and rainfall values are there in the case of from January 2001 to December 2010 in the Bathurst agricultural stations, which we'll describe in the study area. So the SPI values are in the red lines, which indicates how the SPI value fluctuates with the rainfall values. It's not it will consider like how the rainfall values from the past 12 months are leading, because the value indicated here is SPI 12, how the rainfall values of the past 12 months are indicating, and what is the SPI index here. Study area and data. So in this paper they have considered the study area as New South Wales of Australia, which is a very drought prone area, and also they have considered four stations like Baraha, Peak Hill, Bathurst and Yamba. So two stations are coastal and two stations are in the center of the catchment. So on this area is also faced the millennium drought, which lasted in the year of 2001 to 2009. The data for meteorological parameters were collected from scientific information for landowners silo and recorded length. They have obtained the data from the year 1901 to 2018. Now it comes towards the models, which is the important part of our coursework we learned. So in this case, they have considered the LSTM, long short-term memory architecture. So in this case, LSTM is an artificial recurrent neural network architecture used in the field of deep learning. So there are simply can understand like there are three states are there, which is input state, forget state and output gate. So in this case I can give a short example what LSTM actually is. So when we are storing a data and we need to forget the data and store another data, or sometimes we need to add some other data to the previously existing data, we use long short-term memory architecture. So in this case also they have considered these things. Briefly, I can say the input gate determines whether to allow including new inputs. The forget gate decide whether to discard the currently used information as it may or may not be important anymore in the future scenario. And the output gate controls the amount of information that needs to pass through. The input of whole network is in 3D tensor form, which is the sample size, sequence length and the number of features. The sample size is equals to the training data set, which in the study was from 1901 to 2000. The sequence of length is temporal size of the input data, which would be used to forecast SPI 12. And here in the best sequence length was found to be 12. In simple terms, the last 12 months value of the variables is used to forecast the 13th month's SPI 12. It will also help us to predict which for the forecasting of the data for the model, how many future month we can predict using this model. So this also, it will be very helpful to know how many like forward months we can predict from this using this LSTM architecture. This illustrates the LSTM structure, where we can see here in this case the first there are different types of variables like rainfall, the Indian Ocean dipole, the Nino, Nino 4, Nino 3.4, Nino 3. So all these values are there, and also these are the model parameters. Then we use the training data input and the testing input, where the training input will be the data sets which belongs from the year of 1901 to 2000, and the training testing data will be the from the 2001 to 2018 data sets. So note that input never includes the YT. Also, this LSTM sequential regression learning framework, which is trainable with weight parameters, have been used, and then it will get some it will get our the Y train and Y test, and also we will get our the training output. After training output, we will get this SPI 12 forecasting, which is also helpful for evaluating the metrics using the RMSE and R-square value, and interpreting the model using the SHAP algorithm. So this is the basic structures we are going to study in detail, or also they have been used in this study. In this study, they also have described a lot about the recursive approach and the direct approach. So in this study, they have considered the direct approach. So we'll little bit discuss about what is the recursive approach and what is direct approach. So in this case of recursive approach, the parameters of the sequence length are used to forecast past monthly shift, and thereafter the forecasted result will use to determine the next month's or next time steps value. But in case of direct approach, the parameters which have been previously set up, those values will describe the means which will forecast the ahead all times. It does not consider the forecasted values, but it will consider all the previous data set, and also it will forecast for all the time steps. So in case of Mishra and Desai in the year of 2006 forecasted the SPI using an artificial neural network for the conservative river basin, and in India, which examined both the approaches. Their study found that forecasting at higher lead times using direct approach produced better results. For that's the reason why the author here considered the direct approach for the study. The activation function used for all the station data was sigmoid, and the loss function used was mean square error, and the optimizer used was Adam. Now we'll discuss about SHAP methodology. SHAP is the safely additive explanation value, which is a general algorithm which used for in game theory, which it determines an individual player's contribution to a collaborative game. So what does this function do, or this methods do? This helps to determine what a contribution, how much the player contributed in a particular game. If he or she have been contributed maximum, their points will be maximum. So in this case also, what factors generally help for leading or forecasting the drought is being considered here. So here we will get to know what is the main factor which contributes to the drought. So in game theory, this concept was applied for importance of a single player in a collaborative team game. So in this case, in this study, our collective collaborative player will be different climatic variables, but the individual players will be like Nino 3, Nino 4, Nino 4 point, or the rainfall values, or the IOD parameters. So the safely values estimate both magnitude and direction of each features towards the model's outcomes. Positive indicates more contribution in right direction, and negative indicates contribution in opposite direction towards achieving the prediction outcomes. So here I also represent the mathematical form which is represented in the article. SHAP provides multiple explainers for different AI-based models like tree explainer, kernel explainer, gradient explainer, and deep explainer. Using the relevant explainer, four different types of interpretations can be conducted, which are summary plot, dependence plot, individual force plot, collective force plot. In this study, the author have explained about the author have used the summary plot and dependence plot for getting the result. What parameters is influencing the forecasting of the drought. So the dependence plot explains the effect of a single feature has on the prediction made by the model. The individual force plot explains effects of a single feature affecting positively or negatively towards the model result. The collective force plot is similar to individual force plot, with the only change being adding all features in a single diagram. Although there are several types of plot, readers are referred to this article for an in-depth detail. Now we are going to discuss about the results of the results of this study. So in this case, the author obtained author have described like in three sections. One is LSTM architecture, the summary plot, and dependence plot. The summary plot and dependence plots are indicating the SHAP methodology, how this parameters, which parameter is more strongly influencing the drought forecasting. And in case of LSTM architecture, how the model predicted values or the LSTM predicted values or forecasted values are resembling with the actual obtained data set. Here we'll go to get to know that. And in case of LSTM architecture, we'll also go for evaluation of the matrices like the RMSE value, NAC values, R square values. So now we'll move for the next slides. So in this case, the statistical methods like the RMSE, which is root mean square error, and the R square, which is coefficient of determination, and the Nuss-Scottville efficiency, which is NSE, are the representation of how the statistically the model and the predicted and the observed data are aligning. So in this figure we can see for the four stations which have been considered in this study, how the model predicted value and the actual value are the forecasted value and the actual value are going in line. So when the value of the R square will be more than 0.9 in every case, which indicates it's very good at prediction or very good at forecasting the drought at SPI 12. Also here we will look for the all these values are more than 0.9, so having a very good coefficient of determinations which ranges from 0 to 1. So 1 depicts the exact match with the models that forecasted data and the observed data. So also contrarily, a lower RMSE value illustrates better performance. So in this case, RMSE value is generally less than 0.3, so which indicates the work efficiency or the efficiency is better, like the performance of the model is better. The advantages of using LSTM over conventional machine learning model is that it learns variable weight across the time states, unlike learning uniform weights in the later case. So as LSTM gives variable weights, it is very useful for the model forecasting. As anomalies exist among the variables, decay over weights across time periods is necessary. The forget gate is the LSTM in architecture captures the decay weighted lag lead sequence relationship effectively without the vanishing gradient issue, thereby affirming its use over conventional neural network architecture. As the SPI values are generally useful by the precipitation value, so it is expected the rainfall to be the most important factor. For all the locations, Nino 4 plays the second most important factor, post that there is no clear trend in the end. As we go from top to bottom, the bottom half becomes less significant based on the mean SHAP values. So in this case, we are observing in every stations the rainfall is the important factor, and also other than rainfall, nano 4 is the important factor. Previous researchers on drought forecasting in the region has also shown Nino indices playing a key role, and this also being satisfied in this study. However, it is important to note that not all the locations show the same variable significance, and the actual mean values SHAP are minimal. As and when higher lead times are forecasted, these indices would play a more important role, thereby increasing their mean SHAP values. Such variable importance plots can also be illustrated using different machine learning models. So next we will discuss about the dependence plot, how the dependence plot of the SHAP algorithm comes. As previously we have seen that in there are 8 variables which have been included for the forecasting models, and the dependence plot feature the SHAP can help in understanding the dependence of all variables in including forecasting SPI 12. Herein we present the relationship among the two most important variable for all the location, which is rainfall and Nino 4. The left coordinate represents the SHAP values, and the right coordinate exists representing the Nino 4 for all the 4 stations, and the rainfall values and the color ranging from blue to pink showing its importance from low to high. In general, a monthly rainfall of more than 100 mm increases the prediction result, and when it is less than 100 mm there is no clear trend and depends on the location and Nino 4. As an example, in case of Bathurst, there is no linear trend, which is the same in case of Peak Hill and Yamba. The spread in this plot suggests that overt other variables must interact with rainfall. However, in case of Baraba, a low rainfall with high Nino 4 values increases the model prediction. Such critical analysis is essential and can be performed among all the variables. However, when looking at the SHAP values for the summary plot, the first 2 variables of the Bathurst and the peak values or first 3 variables of Baraba and Yamba were the most critical. These dependence plots are essential, but it does not indicate how temporally these variables are behaving or helping for the prediction or the forecasting. So in this case, we'll go for the dependence plot which shows the temporal variability. When the author examined the dependence plots under different temporal ranges, the temporal ranges here is they have illustrated 3 temporal ranges like the 2001 to 2010 and 2011 to 2018, and also the December, January, February like seasonally temporal range. So it depicts the dependence plot between rainfall and Nino 4 at 3 different temporal ranges, and also it provides contrasting results. The summary plots depict interaction of the rainfall and Nino 4 in predicting the SPI 12 value. Although at the first glance all plots show an upward trend depicting the positive impact of rainfall on SPI, the spread in the plot suggests that the other variable must interact with SPI prediction. As the effect of Nino 4 compared to other climatic variables was more prominent, and therefore the author decided themselves that they will examine the interrelationship only among these variables. As in this figure shows, the dependence among the variables affecting the model's results vary spatially and also temporarily. Such examination provides evidence in understanding the effect of climate indices on forecasting results. It is important to note that this is a preliminary study suggesting that the explainable models towards forecasting droughts and more in-depth analysis can also be done for forecasting at higher lead times. Here the lead time was not that high. Now we move towards the discussion part of this study. The inclusion of climate variable has been found to be improve the forecasting results using data-driven models for longer lead times. However, with the inclusion of several variables in involving lag components, neural networks often succumb to overfitting. So for this case also, we are not going for neural networks anymore. We are going for the LSTM architecture, and the use of Interpretable AI could not only help to explain the model outcomes but also for selecting important features, thereby building a more efficient and robust model. The conclusion of the study was the LSTM architecture can be used for forecast of drought, which leads to R square values of more than 0.9, indicating it is a very good at prediction. And also the use of SHAP helps to understand how climatic indices affect the model results. The summary plots depicts the most important variables, which were rainfall and NINO4. The SHAP dependent plots demonstrate how the inclusion of climatic variables improve the forecasting results. The results indicated that for a monthly rainfall of less than 100 mm, it is improved the forecasting results. Although the dependent plots provides a relative understanding of the variable impact, breaking it into different temporal ranges leads to a more clear understanding how the variables affect various time periods. Now we'll discuss about the limitation of the study. The use of deep explainer in SHAP algorithm is still in its infancy. And also in this study, how to handle the raster dataset for drought forecasting have not been discussed, which would help to examine the spatial variation of the variables. These are not only the limitation of this study, these are also the future scope for going deeper in this field. This is the reference for this study, which can be this paper can be accessed in this link also. Thank you for listening. If you have any question, kindly comment on the comment section.